In this video, we are going to find the square root of a number by long division method. So the method uses long division. It's called a long division. Now let us see. We all know the inverse operation of addition is subtraction. Okay, addition and subtraction are the inverse operations of each other. The inverse operation of multiplication is division. Similarly, the square root is the inverse operation of square. The positive square root of a number is denoted by the symbol root. This is a root symbol. Okay, it is denoted like this. You write a number inside it, that means you're finding the square root of the number inside. Square root of 0 is 0, since 0 square is 0. We have 1 square is 1, therefore square root of 1 is 1. So, okay, see how it's a reverse. 2 square is 4, therefore 4 is the square root of 4 is 2. 3 square is 9, therefore square root of 9 is 3. Observe that 9 square is 81, minus 9 square is also 81. So we can say that the square root of 81 are 9 and minus 9. Because square of a number should be equal to this number. And in both these cases, we are getting 81 if you take the square. So we can say, say that the square root of 81 are 9 and minus 9. Now we talk about positive and negative roots. For any positive number x, there are two square roots, a positive root and a negative root. Positive root and a negative root. The positive root is called the principal square root, denoted as root of x, because x is the number and root of that, and this is the principal square root. The negative square root is the negative of the principal square root, denoted by minus root x. So root x, and they have put a minus sign outside it. That is how we get the negative square root of the number. Square root of negative numbers. So what does do we have a square root of a negative number? If you take a negative number, suppose, so let us see. If in the set of real numbers, the square root of negative number is not defined, because there is no real number that when squared gives the result, negative result. For example, there is no real number y such that y square is minus 1. Since you are not going to square of any number, whether it is positive or negative, it is going to be positive. And therefore, you will never get a negative number for that. That is why y square is equal to minus 1 is not possible. Therefore, root of 4 is 2, not minus 2. Root of 9 is 3, it is not minus 3. Okay? Because when you are taking a square root, you should not you should be getting a negative number. And the square root of that number is not negative because it's not a real number. However, in the set of complex numbers, the square root of negative numbers are defined using the, so for complex numbers, this were all real numbers. There's another set of numbers called as the complex numbers. There we use an imaginary unit I, and I is equal to root of minus 1. And once you put root of minus 1 and then put root 9, then you will get minus root of minus 1. Okay, that is I you will get. To determine the number of digits in the square root of a number. Now, let us see how to find out how many digits will a square root have for a particular given number. We take a table and try to analyze it. See this, number is 2, its square is 4. Okay, so 4 is the smallest one digit perfect square. 1 is not a perfect square, 2 is not a perfect square, 3 is not a perfect square. 4 is the first number, which is a single digit, and it's a perfect square because square root of 4 is 2. It's a perfect square. Similarly, we try for 3, 4, 5, 6. And you say 9 is the greatest one digit perfect square. 16 is the smallest two digit perfect square. That means 1, 10, 11, 12, 13, 14, 15. All these are not perfect squares. 16 is the smallest two digit perfect square. And if you go like this, 81 is the largest two digit perfect square or the greatest two digit perfect square. And 100 is the smallest three digit perfect square because square root of 100 is 10. That is the smallest perfect square. 961 is the greatest three digit perfect square because its square root is 31. 1024 is the smallest four digit perfect square. And the largest or greatest four digit perfect square is 9801, whose square root is 99. Clear? Now, if you observe here, one digit, two digits. So for one digit and two digit, its square roots will be single digit. So you can say if the number of digits is 1 or 2, its square root will have only one digit. Number of digits. It's a two-digit number, it's a one-digit number. Its square root will have only one digit. Three-digit, three-digit. Four-digit, four digits. For three-digit and four-digit, the square root will have only two digits. So see the next statement. If the number of digits is 3 or 4, its square root will have only two digits. So what we see, it is going out in pairs. One pair, if a pair is formed, you get one digit. Two pairs are formed, you get two digits. Okay. Similarly, if the number of digits is 5 or 6, its square root will have three digits. In general, we can say if a perfect square is of n digits and the number is an even number, then its square root will have n by 2 digits. Or if the number is an odd number, then its square root will have n plus 1 by 2 digits. Understood? So you can determine how many digits a perfect square will have depending upon the number of digits the particular number is having. Now see, this is why we pair the digits starting with the digit in unit space. Because of this concept, using this concept, we start pairing the numbers. In one pair we start and we start from the unit place where we do. So we start from then you have learned no unit tens, hundred, thousands, like that. So we start from the unit place and start pairing it. So now let us understand how to find the square root of a number by long division method with examples. Now I'll write down the step what you have to do it so that you will get an idea and then afterwards we will not write those steps. Find the square root of 529 by long division method. So what should you do? Your first step should be place a bar over every digit of every pair of digits starting from the digit at ones place. Okay, place a bar over every pair of digits starting from the digits in units place or ones place. If the number of digits is odd, then the leftmost single digit 2 will have a bar. Now see here this. Thus, what is this? This is 529. So here 529 is the number. So you start from the units place and put a bar over a pair. The first pair will be here. This will be your first pair. And here you are left with only one digit. So here on this, because though it is not having a pair, you'll put a bar over this. Okay. So you get one digit, one pair. Second, though it is not having a pair, but it is a single digit. So from this word, from the previous word we have learned, that means you will have two digits in this square. To try to find the square root of this number, you will have to, this will give you one digit and this will give you one digit. So your square root will have two digits. Clear? Next, step 2 should be Find the largest number whose square is less than or equal to the number under the extreme left bar. Extreme left bar is this. So you have to find a number whose square is less than or equal to 5. So 2 square and must be, is 4, which is less than 5, and is less than 3 square, because 3 square is 9. So that means 5 lies between 2 and 4, 2 and, sorry, 4 and 9. Take this number as a divisor. This number which we have taken 2 should be taken as a divisor and also a quotient. Take this as a divisor and quotient. That means now, since we have found that 2 is smaller than 2 square is smaller than 5, therefore you have to take 2, and this 2 should be taken as a divisor and a quotient, and write the number under the extreme left bar as the dividend here, which is 5. So this is the thing, the number is here. So 2 is a number which we have chosen. So you write 2 here as a divisor and a quotient. So 2 2s are 4. Write 4 here. Subtract it. What will you get? 1. Clear? So here, that means you take a number which is 2 2s are, 3 3s are, 4 4s are. You should take that so that it should be less than or equal to this particular number, and then subtract it. Okay. Then divide. Okay. Divide it and you get a remainder 1. In this case, we are getting is 1. What should be the next step? Bring down the number. Okay. Which is to the next. Okay. Bring down the number under the next bar. That is 29 in this case, to the right of the remainder. And so now see here how it is. This is the thing. What we have done, this much we have done. Now this next number, this pair, I have to bring it down. So in this case, 29, we are bringing it down. Should be written next to the remainder. So now your dividend is 129. Clear? Now what you have to do? Double the divisor. This divisor should be doubled. Means add 2 to it again. Okay. Add to it. Cool. So double the divisor and enter it with a blank on its right. Double this divisor and enter with a blank on the right side. Okay. Just don't write. You keep one blank space here. Then why are you keeping it? So here. Next step you'll understand. Guess the largest possible digit to fill the blank, which will also become the new digit in the quotient. You choose a number here, which will be written here also, such that when the new divisor, so your divisor will be this and the new digit, is multiplied by this new number, new quotient, the product is less than or equal to the dividend. Should be less than or equal to dividend. Now you see here the last digit is 9. So 9 is a odd number. So 3 3s are 9. So let us try 3. See here. This is how so much is done. Now see here. In this case, 42. Suppose I take 2 here. 42 into 2 is 84. It is smaller. So try the next one. 43 into 3, 129. Yes, it's 129. So we choose the new digit as 3. So write 3 here and write 3 here also. 3, 3. Okay. So 123, 43 into 3 it should be. 43 into 3, you're getting 129. Subtract it and get 0. Okay. So your all the digits are over and you have got a remainder 0. Finish this now. So step is, since the remainder is 0 and there is no digit left in the given number, therefore square root of 529 is 23. Clear? So this should be your answer. I'll take one more example so that you get to know the steps. If you remember the one or two sums, if you start doing remembering the steps, automatically things will be clear. Now let us see. Find the square root of 4096 by long division method. Place a bar over every pair of digits starting from the digits at extreme one's place. If the number of digits is odd, then then the leftmost single digit 2 will have a bar. That should be the condition. Now writing the whole thing so that you don't forget what it is. So now what is our number? 4096. So you should put a bar over this, and this is second bar. So you'll get one bar here, you'll get one bar here. So you're getting two pairs of numbers. Getting it? Now, next step. As we do, first pair is this extreme left is 40. Should get a number which is less than 40. So you see here 6 square is 36. 7 square is 49. 49 is greater. 6, this is only 40. So we go for 36. So now see here, number written, take 6, 6. 6, 6 are 36. Subtract it. What is the remainder? 4. Okay. Getting it? So I'm not reading out this. So this, in case you want, you can just refer to it. Now, next step. Bring down the number. Next number have to be brought down. We have done this much. Now this is the next number. This has to be brought down. Bring it down. Now your dividend is 493. Add 6 to it, double it, that is. This is done so much. Add 6 here. Because you're going to double it. It becomes 12. Put a blank here. Now you have to take a number so that it is equal to or less than this. Last number is 6. In which table do you get 6? 4 4s are 16. 6 is there. 6 6 are 36. 6 is there. So you got only two options, either 4 or 6. But this number is smaller. So we should see here how it is. I have to get it. 124 into 4 is 496. Or 4. Next number is 6. 6 will be bigger because you're getting here itself. So take 4 here, take another 4 here, and subtract. This is 0. The square root of 4096 is 64. Okay. Hope I am clear. You got the video is at your disposal. You can go through it 2-3 times till you get to know the method, the steps. The steps are clear, things will be fine. Okay. Now let us take a few examples. Find the square root of the following numbers. One by one, we'll try it out. Let me take a first number. Say, let me take a big number. 27,225. Okay. So first, starting from your unit place, you have to make a pair. When you're making a pair, the first pair is this. Then this is your second pair. And you are left with a single digit. Right, that's it. First number is 2. So 1 ones are 1, 2 twos are 4. 4 it becomes this is bigger. So we just go for 1. 1 ones are 1. Subtract. Bring the next. Add 1 again. 2. Bring the next pair down. 72. Your dividend is 172. 2 here, if I put here, 20 in 20s it will be 21, 22, 23, whatever you take. So that it should be closer there to this 172. So this is 6. I have taken 6 here. So 26 into 6. How much it is? 156. 6 6 are 36. 3 remainder. 6 to 12, 13, 14, 15. So if you take 7, it will become bigger. So 1. Subtract it. There is 16 difference. Add 6 to this. 32 and a blank space. Now you have to take one more digit here. Bring this pair down. Now your dividend is 1625. Last digit is 5, so it should go in 5 table. So let us try 5. So 325 into 5 is 1625. Subtract it, 0 is a remainder. That means your square root of 27,225 is 165. Clear? Now let's go for the one more. 36,000, 3,64,816. This is a number. So one pair, two pair, three pairs we are getting. One pair, two pair, three pair. So you're getting three pairs. And now you see here, you're getting three pairs. Therefore, you'll get three-digit number. Here also, one pair, second pair, and a single digit. You're getting three pairs. So depending upon the number of pairs, so many digits will be there in the square root. Now, first number is 36. You know 6 6 are 36. Take 6 6. How much? 6 6 are 36. Put it. Subtract. 0. Add 6. 12. Bring the next number down. 48. Now you see here, 1, 2, if I take a number, it is 120 something. But here I'm having only 48. So it doesn't go well. I cannot take even 1 here. So what I do, best number is 0. 120 into 0 is 0. So 48 minus 0 is 40. Add 0 to this. It should be like this, 120 and 4th digit. This is a space for the 4th digit. Now add 48 minus 0 is 48. Bring the next down. Now 16. 4 4 the, so take 4. 1 2 0 4. 4 4 are 16. 4 2 are 8. 4 1 are 4. Going well, 0. So square root of 3,64,816 is 604. Okay. In case, that's why you are taking these sums. All the sums which I'm taking are a little typical so that you get to know. Now see, this number doesn't go. So what is the option? 0. Okay. You get an idea how to do that. So by the time you go through all the sums here when I'm showing you, you'll get to know and you'll be able to handle all types of sums. Now see the next one. 4,36,887. Again, one pair, second pair, third pair. 6 exam. 36. Subtract. 7. Add 6. 12. Bring next 68. Now 6. 126 into 6. Okay. It will be 756. Subtract it. 12. Add 6 here. 132, 1 fourth digit. There is a blank space for the fourth digit. Bring this pair down. 87. Now you see here 132. So is already 1,300. If I take any number here, 1,320 plus 21, 22, 23, whatsoever. But what is my dividend? 1,200. So how can I go for that? No, I'll have to take 0. So 1,320 into 0 will be 0. Subtract it. You're getting it 1,287. So what do you say? Square root of 4,36,887 is approximately 660. Why we are saying approximately, not perfect square? Because we are not getting 0 as a remainder. Clear? It's not necessary every number should be a perfect square. There are numbers without which are not perfect squares, and they tell you find the square root. So how far you should continue? Till you get the last pair down. Till you bring the last pair down, you should continue your division. As a long pair comes down and you get a remainder, then stop at that stage and say it's approximately. Okay. Clear? You should know that. Why did we stop here? That's all. Now see this next number. See this how it is. Here it is 4,90,000. One pair, second pair, 7. 49. What is 49? 7 7. Take 7 7. 49. Subtract 0. 7 plus 7, add it up. 4, 14. Bring the next pair. Next pair is 0 0. It's all 0. Here I have of 140 plus something I'll get. Cannot be 0, so I take a 0 here. 140 zeros are 0. Subtract. Again I get 0. Bring the next pair down. Add 0 here. Again 140. Again it has to be 0. Take 1 0. It will become 0. Clear? So what is happening is when there are zeros, actually this is, I just followed the method to show you that you 0 0. Otherwise, once you finish of this, from each pair, put a 0 in the answer. From this pair, you put a 0 in the answer, you'll get the answer correct. Clear? But to follow the step, I've just done the whole thing. So here the square root of 4,90,000 is 700. Clear? Now let's take 120. 1, 1. Now say a 1, 1 is a 1. Put it. Subtract. 0 plus 1, 2. Bring the next pair down. Now what you should take is already 21. So if I take 1 here, it will become 21. So take it. 21 into 1 is 21. Subtract 0. So you will get square root of 121 is 11. And you know this value at least. You know this number by heart. Square root of 121 is 11. 11 square, 11, 11 are 121. Clear? This is the numbers when the whole numbers are real. Now let us take 2-3 examples about when they are decimal numbers. Okay? What will be the case when they are decimal numbers or prime numbers? So this is not a perfect square because we have getting a remainder. That is the reason. Okay. Why it's not a perfect square this number? Because we are getting a remainder. Now find the square root of the following up to 2 places of decimals. Okay. Now these are decimal numbers. Now this long division method can be used to find the square root of decimal numbers, non-perfect squares, everything. The other method which are there, that is what you call as a prime factorization method, repeated subtraction method. All these methods don't give a perfect answer and they are very cumbersome and you cannot easily decide what should be the number. Therefore, division method is a better method where you can find the square root of any number possible, irrespective of what type of number, whether it's a prime number or a composite number or a decimal number, all it's applicable to all numbers. That's why this method I have taken up first so that you clearly understand it. Now let us see this. 12 point, number is 12.4609. Now here, when there is a decimal number, the pattern in which you put your bar over the number slightly changes. Here it is your decimal point. So first, starting from the unit place, you will put a bar there. Then the decimal, after the decimal point, the numbers which are there, first you will start with the immediate number, which is the pair which is immediately after the decimal point. So this should be a first pair, and after that, this becomes a second pair. Clear? So from the left side decimal point, from the decimal point, when you are going to the right side, it is starting from the left side. And after the decimal point, you start and go towards the right hand side. Okay. Before before the decimal point, pairing is done to the left side. And after the decimal point, pairing should be done right side, starting from the number immediate after the decimal point. Our first number is 12. 3 threes are 9. 4 fours are 16. So 3 threes are, because 4 4 16 is greater than 12. So we start with 3. 9. Subtract 3. Add 3 to that. 6. Now, before you take a number which is after the decimal point, put a decimal point in your answer. Put a decimal point and then bring down the next pair. Bring down this 46 down. So first put a decimal and then take the number after the decimal point. Then bring down the pair. Now you have to take a number which is closer to this or less than this. 5. 65 into 5 is 324. Subtract it. 21. Add 5 here. It becomes 70. Bring the next number 0, 9. Number is 9. Should go in 3 table or which it will go 7 table. 7 sevens are 49. So it is going in 3 table. It try 3. 3 threes are 9, 0. 3 sevens are 21. 0. The square root of 12.4609 is 3.53. You're getting a remainder 0, so that means this number is a perfect square. Next, 20.3. Now, from here, one pair, this will be your first pair, but on this side, there is no pair, single digit. But in decimal, I want 2 places of decimals. I want 2 places. This is your first place, this is your second place. This is the 2 places of decimals I want. So what I have to do, I'll have to add one 0 here, make a pair, and take 2 more zeros and make the second pair. If there's no 0 here and they are asking you, take 2 places of decimals, 3 places of decimal, as many decimals you want, that many pairs you have to keep forming. I want 2 places of decimals, so they have formed 2 pairs after the decimal point. First number is 20, 4 fours are 16. Subtract 4. Decimal, now you have to take a number after the decimal point, so you should put a decimal here first. Add this here, put a decimal there, and then bring 30 down. Okay, now 8 and put a number, so in 80s it will go. Take that, 5. 85 into 5 is 425. Subtract it, it is 5. Bring the next pair of zeros. Bring this 2 pair down. 85 plus 5, 90. Bring the next pair down. It is 500. So if you put a 0 here, it will be 900. But I have only 500. So I'll have to take 0 here. So 900 into 0 is 90. So it will be, your remainder is 500. So here I say 20.3 is approximately equal to 4.50. It is not a perfect square because we are still getting a remainder. Clear? Now, instead of taking a demo, I'll take a single digit number. Now, this is not a perfect square because we are getting a remainder. Now, let me take a single digit, 2. Square root of 2. Only one digit is there and they are telling me to find the square root of 2 places of decimals. So what I have to do, I have to put a point here, take 2 pairs of zeros. Now this will be a 1 bar, 1 bar, and here on this you will put a second bar, third bar. Number is 2, so it is 1, 1 is a 1. Subtract it, you'll get 1. Add 1, 2. Now bring the next pair, but it is, this pair is after the decimal point, so you'll have to put a decimal point in the answer. After that, now you bring the next pair down. Now 100 is this, it will be in 20s. So what I do, I go for 4. 24 fours are 96. Subtract it. Bring the next, add 4 here. Bring the next pair. Now 200. This will be in 200 and I got only thing. So 200, 2, if I take 2, it will become more than 400. So I'll have to go for 1. So it is 281 subtract 190. So that means the square root of 2 is approximately 1.41. Okay. So these values like square root of 2, square root of 3, we need we have to use it in calculation. So we how to so a single digit or a prime number also you can find the square root by long division method. By prime factorization method or other methods you cannot find it. A square root of 2 is not possible to find by the other methods. This method is perfectly okay. Is not a perfect square because we are getting a remainder. Okay, you can go further, you get many more also, but this is. I hope you have understood this. If you are watching this channel for the first time, please click on the like button and subscribe for more such videos. I think you will be. Thank you.